Hi, today we have come to a new chapter on proving of trigonometric identities. Now today we will learn how to make use of three identities. They are called the Pythagorean identities. Now your first identity, which I'm going to prove to you, is sine square x plus cos square x equals to 1. Now the other two, you will find that we can derive from the first identity. Now let's say there's a right angle triangle. The angle x is here and the opposite side is b and this side is a. The hypotenuse, we call it c. So c is equals to square root of a squared plus b squared, and that is the Pythagoras theorem. Now let's write down what is sine x. Sine x is given by b over c. Now cos x is given by a over c. Now let's do a sine square x plus cos square x will then be equals to 1. Okay, so we do, let us write down sine square x plus cos square x will be equals to sine square, I have b squared over c squared, and cos square I have a squared over c squared, and these are like terms, the common denominator being c squared. So you have a squared plus b squared over c squared. Now a squared plus b squared is a squared plus b squared square root is c. So this will, you'll find that this will be equals to c squared over c squared, which is equals to 1. Alright, so we have proven the first identity. Now let's look at the second identity. Now, so you have sine squared x plus cos square x equals to 1. Now you want tangent squared, you have 1 plus tangent squared, you want tangent squared to appear in the identity. So what you do, you can divide by cos squared on both sides, cos squared x. So you have, now, so you have tangent squared plus 1 over here, so I rewrite it will be 1 plus tangent square x over 1 over cos square x. Alright. Now 1 over cos x is secant x. So you have 1 plus tangent square x is equals to secant square x. So what now we have proven the other, the second identity. Now if you, for the third identity is the same, alright, instead of dividing cos squared, you divide by sine squared because you want cotangent squared. Alright, so if you divide by sine squared, what will you get? Okay. Now if we divide by sine squared, what will you get? You have 1 plus cotangent square x. Alright, and then this will be 1 over sine squared. 1 over sine is cosecant. Alright, 1 over sine is cosecant. So 1 over sine squared is cosecant square x. Alright. Maybe we call this 1. Alright, how did I come to here? It's 1 divided by sine square x. Okay. Now we have proven the three identities. We will now make use of the three identities that we have learned to prove the following identities. Now question 1, you are asked to prove tangent x plus secant x is equals to cos x over 1 minus sin x. Now you look at this. This is two terms, all right? And here is a single term. It is always quite hard to split a single term into two terms using partial fraction. It is easier to combine it. And look at the right hand side. Now on the right hand side, you have sine and cos. Here is tangent and secant. So what we can do is we change the tangent to sine over cos and secant to 1 over cos and see what we can do from there. So the left hand side, LHS stands for left hand side, equals to sine x over cos x plus 1 over cos x. Now these are two like terms, we can combine it, and that gives us 1 plus sine x over cos x. Now it's quite different. Look at the denominator and the numerator. Alright. Now what we can do is we can force it. We make the denominator to 1 minus sine x first. Or we can make the numerator, it's really up to you. Okay. Now let's make the numerator. So let's say we times cos x over cos x. Below we get denominator, we get cos square x. Now the numerator we have cos x into 1 plus sine x. Now what is cos square x? Cos square x is actually 1 minus sine square x you learned previously. Alright, 1 minus sine square x. Maybe I just write here cos x 1 plus sine x over 1 minus sine square x. Now 1 minus sine square x, you learn the identity of difference of two square. A square minus b square is a minus b, a plus b. Okay, and that gives us cos x over 1 plus sine x over 1 minus sine x over 1 plus sine x. Now these two are identical, so you can cancel. And you find that this is equals to your right hand side. Alright, RHS stands for right hand side. So we have proven the first identity. Now let's move on to the second identity. The second identity we are asked to prove 1 over 1 minus cos x plus 1 over 1 plus cos x equals to 2 cosecant square x. Now again, it is quite, this is a single term. It's hard to break a single term to a two term. It's hard to break one term into two terms, but it's easier to combine. So let's do from the left hand side. So the left hand side, now what will you get? You get denominator is 1 minus cos square x. The top will be 1 plus cos x into plus 1 minus cos x. These two terms we can cancel. So that leaves us with 2 over 1 minus cos square x. 1 minus cos square x, we learned from previously that that is equals to sine square x. It's from the identity of sine square x plus cos square x equals 1. So we get 2 over sine square x. And that gives us 2 cosecant square x. 1 over sine is cosecant. Alright, so 1 over sine square x is cosecant square x. Alright, and that is equals to our right hand side. So again, we have proven the second identity. Let's move on to the third and fourth. Question 3. In question 3, you are asked to prove secant x plus 1 over tangent x is equals to sine x over 1 minus cos x. Now, most people, including me, are more familiar with sine and cos rather than secant and tangent, especially secant. So it is always easier to prove from something that we are not familiar with to something that we are more familiar. It's like simplifying. So let us start off with the left hand side. Now let's express the left hand side in terms of sine and cos. 1 over secant, secant is 1 over cos, so it's 1 over cos x plus 1 over sine x over cos x. Now this one we can express as a single fraction. So the numerator can be expressed as 1 plus cos x over cos x. Then when it's divided by this, so we need to flip this and we change it into a times cos x over sine x. Cos x and cos x we can cancel away. That reduces it to 1 plus cos x over sine x. Now, you look at this, there's two ways that we can approach. We can force it, alright? We can force the numerator to be the same. That means we times sine x over sine x. Or we can force the denominator to be the same. The earlier example, I forced the numerator to be the same. Now I force the denominator. I mean, you can do the other way also, it doesn't matter. Huh? So times 1 minus cos x over 1 minus cos x. The numerator will become 1 minus cos square x, which is sine x. 1 minus cos square is sine x, sine square x, because sine square x plus cos square x equals 1. And this is sine x over 1 minus cos x. Alright, if we change this to sine square x, okay, that will leave, I mean, the sine x and sine square x can cancel. That we get sine x over 1 minus cos x. Alright, this is equals to the right hand side. Proven. Now let's proceed to question 4. Now in question 4, you are asked to prove cotangent square x minus cos square x is equals to cos square x times cotangent square x. Now likewise, it should be easier to prove from the left hand side to the right hand side, because this is two two terms to one term. So let's combine these two terms together. So cotangent squared, I can put it as cos squared over sine squared. Cos square x over sine square x. Then I have minus cos square x. And this is equals to the left hand side. Okay. Now, let's change it to the common denominator. Okay, that gives us to cos square x minus cos square x times sine square x over sine square x. Alright, and we can factorize the cos square out. So you got cos square x into 1 minus sine square x over sine square x. Now what is cos square over sine square? Cos square over sine square is cotangent square x. Tangent is sine over cos, so cotangent is cos over sine because cotangent is 1 over tangent. So you got cotangent square x. Now what is 1 minus sine square? 1 minus sine square is cos square. And that is the right hand side. Again, we have proven the identity. For that, we have come to the end of this video. Now, if you like our video, please press the subscribe button. Have a nice day and thank you very much.